Hello everyone, my name is Trujillo and I'm going to present my poster today on additive manufacturing of personal protective equipment during COVID-19. Just want to say thank you for taking your time and watching over this video. In February, it became clear that COVID-19 was spreading rapidly within the United States and New Mexico. It also became apparent that this pandemic exposed the shortage of medical equipment for healthcare workers needed to fight this crisis. It was this shortage where we found an opportunity. We felt that with our knowledge of engineering and 3D printing, we could assist in meeting the demand of this shortage. This was accomplished by engineering, designing, and prototyping personal protective equipment such as masks and face shields. We knew that when dealing with the medical equipment, there would be a lot of regulations and standards that must be met. In response, we primarily did extensive research on the FDA requirements of PPE and utilized other resources within the medical field. We found and concluded that the production of the face shields for frontline workers in the pandemic was the most feasible option because of the easier FDA requirements. Face shields are also smaller and easier to produce, allowing for us to produce more in a shorter amount of time. The production of masks for medical use is not feasible because of the strict FDA regulations. Our other option was to donate masks to higher education institutions for class use only. The major announcement from FDA that prevented us from 3D printing masks was that 3D printed PPE can be used to provide a physical barrier to the environment. However, 3D printed PPE are unlikely to provide the same fluid barrier and air filtration protection as FDA cleared surgical masks and N95 respirators. Additive manufacturing of a face mask must follow strict guidelines set by the FDA. For example, if the 3D printer makes complete layer in one round and then goes back to the starting point to do next layer, that side of the component has more time to cool and harden. This is not good for the precision of the product. The best way is to put layer by layer when both are still hot and soft. Similarly, the space between each line of the build path and the path speed will change the amount of melting and remelting that the boundaries of each line of material will experience. In other words, the dimensions of the final product will be different from the original design. It is crucial to healthcare workers' safety for the face mask to be tight because it should protect them from inhaling the virus particles on the molecular level. To reach such precision of the face, masks should be manufactured at a proper facility. We could not risk a mistake and expose healthcare professionals to be infected. Therefore, we did not consider 3D printing face masks for further distribution to doctors and nurses on the front lines of the coronavirus pandemic. Since our research concluded that we were not able to produce 3D printed face masks for healthcare providers, we did not want to give up on the idea completely. During the research, we discovered that we could donate 3D printing masks to schools around New Mexico with medical or nursing programs. Every school in our state donated their supply for surgical and N95 masks to frontline workers for COVID-19. For example, Santa Fe Community College donated all their medical equipment, including PPE, to medical workers who are fighting the pandemic. It is uncertain what school will be able to restock their medical equipment, including face masks for educational purposes, and students are needing it to graduate. We 3D printed and donated masks to schools so medical students can have proper medical training for their degree. So only the additive manufacture of face shields proceeded as planned due to the research. The drawings for face shields were designed and approved by FDA. In the best interest of healthcare workers, professionals was to follow the existing design because 3D printed PPE may be unlikely to provide the same level of protection as conventional already Authorized products. We 3D printed shields that can be wiped. We 3D printed shields that can be wiped down and sanitized, enabling them to be used multiple times over a period of time. After printing the base of the shields, the product After printing the base of the shield, the production process of the product continued with manual assembly. To attach the transparency sheet, we used standard 3-hole punch to manually create holes for the head strap attachment point. Before securing 2-3 rubber bands on the back of each piece, we cleaned the 3D printed shield's frames following directions from Center for Disease Control and Prevention. Masks were printed in one piece, thus did not require further assembly. Individual products were then packed separately and placed for delivery. Within the delivery, every product can be sanitized again before use, as plastic materials are easy to clean. For the conclusion, I just wanted to say that the highly demanded face shields were 3D printed and donated to medical health care professionals fighting pandemics, and the face masks that did not reach basic regulatory standards were donated to higher education institutions for class use only. And thank you very much for taking your time and listening to this presentation again. Have a good day. Thank you.